Hello. It's good to see you today. Okay. What are we doing today? You already wrote it down, right? So you already know. We're still on quadratics. Okay. Before we start on what we're going to do today, we need to talk about what we've been doing for the last week or so that we're ready for today. Are you okay with that? How to solve quadratics. You now know 5 ways to solve quadratics. I would like to list them and talk about each one of them. Okay? What's one way we know how to solve quadratics? Quadratic formula. Okay, what's another way? Graphing. Good. Good. I'll go ahead and write that as number 3. Completing the square. What about number 4? This is not in any order, is it? No, just how we're thinking of it. Factoring. Good. And what about the 5th way? Anybody remember that one? Square roots. You okay with those? Remember doing all those in the last week or so? Okay. When would graphing be a good way to solve a quadratic? So if we graph a quadratic, what are we looking for as far as solutions? Where it's crossing the x-axis. So if it's got real solutions, it's going to cross the x-axis, right? So we would do that when we know it's got real solutions. And even more specifically, we would know when it's got nice, pretty real solutions, right? Like 1 and 3, or 5 and -2, or something like that, right? So that wouldn't be a good time for graphing. What about completing the square? When there's not a number in front of the x squared, like so a, when a is 1, and what would be really nice if b was? If b was even, right? Because if b is an odd number and I go to divide it by 2, I'm going to get a fraction or a decimal. I don't want to do that, right? So completing the square would be nice when a was 1 and b was an even number. Okay? What about factoring? When would I want to try that? Yeah, when it's something we can factor, right? If it's something that's easily factorable, we want to try factoring. What about square roots? When there's no x term, right? When there's no x term. When there's an x squared term and a constant, because then we can just get the constants on one side, the x squared terms on the other side, and take square to both sides, right? So when would we do quadratic formula? Any of them, right? Any quadratic can be solved with quadratic formula. Now, for the record, any quadratic can be solved using completing the square as well. But we would not choose it necessarily if that b term was an odd number, right? Okay? Or if it really had an a value, I don't want anything with an a, okay? Quadratic formula we know is going to work every time, right? So we dealt with the quadratic formula at the end of last week. So let's make sure we remember how it goes. Well, let me get a different color marker because that's exciting. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now, I didn't hear very many of you singing very loud. So I'm going to try it again. Ready? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. That was so amazing. That was so amazing. Good job. Okay? So what happens if we have a quadratic except we're not given an equation. But we know because of the situation that it's a quadratic. And we have to make up our own equation. Is that scary? Nah, that's not scary. Okay? Here's the deal. If I throw a ball, baseball, football, basketball, I guess I could throw a hockey puck, or a javelin, or a marker, right? What shape does that thing travel in? It travels in a parabolic shape, doesn't it? Doesn't that make it a quadratic? Yeah. Okay? So, any kind of word problem that's dealing with something being thrown or even something being dropped. Okay? That's going to be a parabolic situation. Okay? So, let me teach you this. I don't know if you've ever seen this before, but just in case you haven't, let me teach it to you. H equals negative 16t squared plus v sub o t plus h sub o. Now, what did I say for this term? V sub o. What did I say for this term? H sub o. Okay? Why am I saying sub o? And do you realize that's not one word? It's sub o. Why am I saying sub? Because in typing, that would be subscript, right? So it's sub o, or sub 0, depending on the situation, yes? So why, have you ever seen that before? Oh, physics? In physics? Yeah, okay. So sometimes the same things we do in math might show up in science. Because they're the same. Okay, as long as we're clear with that. If we're going to use this formula, which we are today, you need to know what everything means, don't you? Okay, so let's see if we can figure out what everything means. Do you know any of it? Do you recognize any letters that might stand for something that you know? Say it louder. Time. So wait, is it this T or this T that stands for time? Oh, both. Okay. So this T and this T both mean time. Okay. Anything else that you might think you might know? Height? Where? Well, I don't know about you, but I see 2 H's. Okay, yes, I do. I do see 2 H's. Okay, thank you for confirming that for me. So which one stands for height? They both kind of do. Okay? H sub 0, that means the height when we start. Okay? A common way that the problem might say it, the initial height. Or another way to say initial is beginning height or starting height. Does that make sense? Okay. If we're using the right mathematical vocabulary, though, we're probably going to say initial height. That's just like very common. Fair enough? Okay, so which one's this then? Yeah, very good. That's our ending height. So what's left? Why would you think that this is initial velocity? Because of this sub-0, right? Sub-O. So, initial velocity. Now, here's the thing about initial velocity. Sometimes in the problem it says initial velocity. Sometimes it'll say beginning velocity or starting velocity. But sometimes it'll use that correct math vocabulary and be more specific. The initial upward velocity, the initial downward velocity, the initial vertical velocity, something like that. Okay, we have to take all that into account when we do this. Does that make sense? Okay, so there's one more thing that we didn't really identify in the problem, and I want to make sure you know what it is. What is that? Negative 16. That's not a variable, is it? That doesn't change, does it? What does it stand for, you think? Is it always negative 16? Or could it be something else? Well, that's kind of a trick question. I'm sorry I asked it that way. I didn't mean to. Okay? What do you think it comes from to begin with? Oh, gravity. Yeah, gravity. Okay? That's from gravity. And in this particular equation, it's talking about feet. Okay? So why would that ever change? If we were talking about meters, that's exactly right. Okay? Does it really make that much of a difference? Once upon a time, the European Space Union Association people and NASA decided they're going to do a project together because it was going to be pretty expensive and they were going to need to share money and scientists and all sorts of stuff like that. Okay? So they start this project, and it's a pretty ambitious project. They want to send a rover to Mars. Right? So they spend, in all, over $1 billion with time and with supplies and with all sorts of stuff, right? They build this rocket, they build this rover, they put the rover on the rocket, they shoot the rocket off, and it goes to Mars. How long does it take to get to Mars? It takes a couple years, right? Maybe 4.5. I really don't remember. That's a guess. I'll look it up in a little while if you need to know. Maybe 2 years? Something more than like 4 days. Fair enough? So they guided this rocket there. They watched it. They did whatever they do when they do that. And as it gets closer to Mars, everybody's super excited because they're about to land a rover on Mars and they're going to learn lots of new things about Mars. And as the rocket releases the rover and the rover starts entering Mars's atmosphere, it blows up. It exploded. So they have to figure out why, right? You can't spend over $1 billion and have something blow up and you're just like, oh, whatever, we'll try again. They got to know why, right? They do this month-long investigation, and you know what they figured out? The scientists in the United States were using feet, and the scientists in Europe were using meters. They're measuring stuff in feet, measuring stuff in meters. $1 billion! Did I say that part? And they didn't even have the communication about what metric system standard system they were going to use. Yikes. So as you know by now, they built another one and they sent it to Mars and it's still there, right? You know that? Okay. I don't know if it's still doing stuff or if it just sits there. I know on its first birthday it played itself Happy Birthday, which was the first song ever broadcast on any other planet besides Earth by us, Earthlings, that I know of. Okay, so I thought that was interesting. So does it really make a difference whether we do meters or feet? Yes. Yes, it does. Okay. So, but the equation, because we live in the United States, and we're one of 3 countries in the world that only use standard measurements, we're going to use feet. Okay. If we were using metric, it would be like 9.8 something. Something like that. Is that correct? Okay. So let's do a problem. Do you see how we're going to have to create our own problem, but kind of not really? Right? A problem's not going to be given to us in the sentence, but it's going to give us enough information to fill in these values, isn't it? Okay. So let's talk about a juggler. I know we talk about jugglers all the time. Okay, let's talk about a juggler. And this particular juggler, I mean, he's pretty good. Maybe it's a she, I don't know. I don't want to be sexist. Okay? This juggler throws a ball up in the air. Okay? And when the ball leaves the hand of the juggler, the hand is actually 4 feet above the ground. But when the juggler catches the ball, it's 3 feet above the ground. That's where the juggler caught the ball. Okay? When the juggler first lets go of the ball, which at 4 feet above the ground, the ball is traveling at 30 feet per second. So, what? What goes where? What do we know? What do we not know? Well, in order to fill out this formula, what do we need? We need H. We need T. V sub 0 and H sub 0, right? So think back to the juggler. What do we know? We know the initial height. How do we know the initial height? Because I told you. How high was the hand of the juggler when the juggler let go of the ball? 4 feet off the ground. So is that H or is that H sub 0? Okay, so 4 feet. What else do we know? We know the ending height. When did the juggler catch the ball again? 3 feet. Where's that? Yeah, that's really the other height, isn't it? The ending height? 3 feet. What else do we know? 30 feet per second. I might have said meters, I'm sorry. Get distracted by that sometimes. 30 feet per second when it left the juggler's hand. So what do you think the question is going to ask you in this problem? The question is going to say time? Question mark? What's the question? How long was the ball in the air? You okay with that? Okay. So let's fill in what we know into this formula. H is 3. Negative 16 is just part. It's just there. What about T? I don't know it. T squared plus 30T plus 4. What should I do? Tell me why you would add 16T to both sides. So no, the only problem with that, isolating the T variable, is that I have 2 of them. I've got one here and one here. If my velocity, what would happen if my velocity was 0? And so that would be 0, right? 0 times T would be 0, and so I could do exactly what he said, right? I could put the T squared on one side and the constants on the other side, and I could solve for T that way. But since I have a T squared term and a T term, what do you think I want to do? Yes, sir? Probably I want to use quadratic formula, and if I do that, I need to get it equal to 0, don't I? Okay? Like 2 or 3 of you said that, but we were in a conversation, so I just wanted to wait. I wasn't just ignoring you. Fair enough? Okay. So 0 equals negative 16t squared plus 30t plus 1. Is it still, you think, the best idea is use quadratic formula at this point? I don't know about graphing. Completing the square. This is not A, so probably not completing the square. Factoring, what multiplies to be negative 16 and adds to be 30? I don't know about factoring. I don't think that would probably be the easiest. And we already decided we can't do square roots, right? So you're right. It does look like quadratic formula would be the best choice right here. Okay? If quadratic formula is the best choice, let's identify our variables. There's A. There's B. There's C. Okay? For the record, I had a little struggle today because people are wanting to tell me that A is negative 16t squared and B is 30t. Tell me why that's not quite correct. A is just the constant, isn't it? B is just the constant. It's not the variable, just the coefficient. Okay? So now we need to plug it into our quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. It's harder to write when there's numbers. You'll be okay. Thank you for being patient. X equals negative 30 plus or minus the square root of, well, 30 squared is 900, isn't it? Okay, let me rephrase that. 30 squared is 900. 4 times negative 16 times 1 is negative 64. So what goes under the radical? 964 all over negative 32. Okay. Do you know the square root of 964? Yeah, me neither. And based on where that number is, it doesn't seem like it's a number that we can find the square root of, does it? Even some real quick check with the calculator will show you it's not like a whole number, is it? Okay? So in the past, we've just tried to break down 964, right? So what did you tell me that the question was that we're being asked about this problem? How much time it was in the air? How long was it in the air, right? So let me get this straight. The question is, how long was it in the air? And our answer is negative 30 plus or minus the square root of 964 over negative 32 seconds? Yeah, that's ridiculous, isn't it? It doesn't make any sense. Now, I got a little frustrated with you last week when every single time I ask you about something like the square root of 12, which is not an even square root, but we can factor out something, you just wanted to run to your little security blanket calculator and give me a decimal, right? And I said, no, we just need to simplify our radical. There'll be time for that later. Well, guess what? It's later. Okay? If we don't get a decimal here, this answer doesn't make any sense. All right? So, in our calculator, let me make sure that we're okay with this. First of all, turn your calculator on. That's important. Okay? I'm going to zoom in on my calculator a little bit so you can see it a little bit better, but we can still see the problem to the side. Okay? I'm going to press Control Divide because I like to give myself a fraction in this particular problem. Now watch what I do, please. Negative 30 plus the square root of 964. Why didn't I put plus or minus? Yeah, it doesn't work. Okay? Over negative 32. Now when I press enter, what did I get? Okay, so today let's round to the thousandths decimal place. What does that mean I'm asking for? Tenths, hundredths, thousandths. 3 decimal places, right? So negative 0.033, right? The 7 would round the 2 up to a 3. You good with that? Now, I need to do it again, but this time with the minus here, right? Let me make sure you guys know about this skill of the calculator, so I don't have to press everything in again. I'm going to up arrow so that what I need is highlighted, and I'm going to press enter. Except now I just need to go over here and change this to a minus sign. .908. Is everybody okay with 1.908? Okay. Zoom out. Okay, so I took the information from the problem, I plugged it into this general quadratic that I have for motion, stuff that's going on, right? Okay, and I solved it with the quadratic formula and got these 2 answers. So I've done the math. Now I need to go back to the question that I was asked in the original problem. What was that question one more time? How long was it in the air? Okay. So I got 2 possible answers. They could both be right, or one of them could be right, or none of them could be right, depending on the situation. Okay. How long was it in the air? Negative 0.033 seconds. Can we ever get a negative answer as our time? Really? How long ago was lunch? Oh, right. If we were solving this, it would end up being a negative answer, right? We're talking about time before where we started measuring, right? So is that possible? Yes, Does it make sense in this problem? No, it does not. So this answer is not correct for this problem. 1.908. Okay? That makes sense as far as an answer goes, right? So we're going to say x equals 1.908 seconds. But before we box it or underline it or triangle it or whatever you guys do, circle it, the last thing that we're going to do before we decide for sure if that's the right answer, we're going to ask ourselves one more question. Does it even make sense as an answer? If I take something and throw it up in the air and catch it again, you just saw me do that, right? Is 1.908 seconds a logical answer? Yes. Right? What if we got 30 seconds? Would that be a logical answer? You don't know my skills. I might be able to do that. But is it logical for this problem? Absolutely not. Okay? But so are we deciding for sure that this is the right answer? Yeah, we are. Okay? Now, I want to go back to this formula thing right here for a second. I want to talk to you about it for a second. Okay? We talked about it a little bit because, well, let me just put it this way. In your book, there are two equations. It gives you two equations it wants you to work with. One of them is if the thing that you're talking about is being thrown, and one of them is if the thing you're talking about is being dropped. Like if I just take it, drop the mic. That kind of thing, right? You see what I'm saying? Well, I want to know if you could actually just use the same formula for both of those things. If I throw a marker, I can measure an initial velocity, right? An initial speed. If I drop the marker, what's my initial velocity? Yeah, 0. I'm not putting anything behind this pen. I'm just dropping it, right? So my initial velocity would be 0, which means that term is what? Yeah, 0. Because 0 times t is just going to give me t, right? Let me help you by knowing this. The other equation it wants to use is when things are being dropped. And here's the other equation. H equals negative 16t squared plus h sub 0. Isn't that what we just figured out? Right? If we don't throw something, if we just drop it, our velocity is 0, so that term would be gone. So I'm not going to worry about you memorizing two formulas. I want you to know this. I'll help you out with it if you need it. But I'm not going to teach you two formulas. You okay with that? Okay? If it's something that's just being dropped, you know the velocity is going to be 0, so that term's not going to be there. Okay? That's even nicer because think about it. This is the situation you were talking about a second ago, where I could just subtract this h from both sides and divide both sides by negative 16 and then square root it using this one instead of quadratic formula, right? Do you have any questions about this? The questions in your homework, some of them have to do with area. I'm not going to give you the area of a rectangle because you know it. I'm not going to give you the area of a triangle because you know it. I know that for sure because that's one of the formulas we've already dealt with this year, right, for our ACT practice. Okay? If you need help, you know you can come and ask. I won't make fun of you to your face. Just teasing. I mean, I'm just teasing about making fun of you to your face. I'm not going to make fun of you any other time when it comes to math. Other stuff, maybe, but not math. Okay? But use this formula. It is in your book if you need to look it up. I would like everyone to look at page 95 in their workbook real quick, please. 95 in your workbook. What problem are you supposed to do on page 95 in your workbook? 7. So do number 7. Now look at page 180 in your workbook. Is everybody on page 180 in your workbook? What does this have to do with what we're doing right now? Nothing. It's in the actual book. was very careful to say workbook page 95, but then book page 180. So don't think it's in the workbook, because it's not. You okay with that? I'm thinking about getting some counseling over the Thanksgiving holidays. Not that there's anything wrong with getting counseling. It's good for you. Good for your brain. Okay? Take some time, work on this. See how much you can get done for the end of the period. Are there any questions on this? Peace.